Hey everyone, I'm going to show you my approach to finding the QT duration for project 3. So I use the Pan-Tompkins algorithm, which is something that I'm sure we're all very familiar with at this point. So in the screen on the right, I'm sure you remember the ECG simulator and the moving window integrator, which is the result of the Pan-T algorithm. And I use the moving window integrator extensively in finding the QT duration. I'll show you the assumptions I made right now. So the first assumption was that the end of the T wave and the end of the MWI overlapped, as you can see in this picture on the right. My second assumption was that the Q onset was 180 milliseconds before the peak of the MWI. And my last assumption was that the peak of the MWI minus half the peak WI of the MWI peak in time was equal to the distance between half of the MWI peak and the end of the T wave in time. So this is my approach to finding the QT duration. Using assumptions 1 through 3, I made the approximation at the bottom with the equation QT duration equals peak counter times 2 so that's using assumptions 1 and 3. And then you add 178 at the end using assumption 2. And here's just the code that I used. It's adapted from the peak analysis from Lab 9. In this else if statement, this is just after a possible peak has been evaluated and before it reaches half of its value. And I start the peak counter only if the MWI output is above the threshold that's calculated later on. So that ensures that I'm actually looking at a signal instead of noise. Then below, I just do the peak counter calculation. I set it to 0 after we do all these calculations, and I light up the LED. And here's just the end of the code. This is just a little box right here to make sure that no noise is getting counted for the peak counter. And right here is a video of my live QT duration using the chicken heart. So that's the real-time QT, and here we'll see the blink, right? Oh, I must have missed it. Okay. Well, that's if you guys want to watch it again, I can download my slides as well. So I had a couple of attempts with noise using 10% random noise with the ECG simulator. And the last value on the first image, the QT duration equaling 382 milliseconds, corresponds to the wave on the right. And I have the cursors set so they equal 380 milliseconds. So you can be the judge of how good this is with noise, but I think it's pretty good. And lastly, these are the issues I faced and where I think the future work can go. So my previous approach was trying to find the slopes of the Q and T waves, which looked more accurate on paper, but it's actually a pretty touchy variable and not very robust with noise. But in future work, I would like to use a live ECG, something I didn't do this time. I'd like to calculate the real-time difference between the Q onset and the MWI peak because it's just an assumption and there is variation between those two. And I'd like to attempt this with abnormal beats in people with longer T waves to see if there's any differences in the MWI peak ending, kind of getting at assumption 1 right there. Thank you.